Hey guys, welcome to Safi Mixed. In this video, we will learn the multiplication of a scalar with a vector, or the multiplication of a vector by a scalar. So, what would be the effect of scalar multiplication with a vector? So, for that, let me first draw the representative line of a vector, and let that vector be vector A with this representative line. Now, if I multiply this vector by a positive real number, let's say k be a positive real number, and I want to multiply this k with a, so k times a would give me ka, and this ka is another vector which I call b. Okay, what would b? B would be a vector whose magnitude would be k times the magnitude of A and would be pointing in the same direction. Now let's say k is a number greater than 1. If k is a number greater than 1, then I'm multiplying the magnitude of vector A with the magnitude of k. That I can write like this. I can write this thing as k times magnitude of A into unit vector A, and this is, in fact, this thing is the magnitude of B into unit vector A. So k times the real number times magnitude of A make the magnitude of B, leaving the direction the same. So let's say this k is 2. For example, k is a number which is 2. Then this thing is A magnitude is equal to 2 times the magnitude of A is the magnitude of B, and pointing in the same direction A. So if I want to represent vector B, and this I call vector B. If I want to represent vector B, that means B must be in the direction of unit vector A, and unit vector A is obviously representing the direction of vector A, and the magnitude of B must be twice of the magnitude of A. That means I would draw a line like this. This is the magnitude of A, and then twice of this is this. So B is a vector whose magnitude is equal to twice of the magnitude of A. So B is that vector. Now, if K equaled 3, then obviously the magnitude of B will be thrice the magnitude of A, and this length would go to 3 times the length of the line of vector A, representative line of vector A. So if we multiply the conclusion, the crux of this is that if we multiply a vector with a real number with a positive real number, the positive real number only changes the magnitude of vector, leaving the direction unchanged. Now, for example, if this k is 1 by 2, then I would write this as 1 by 2 into A, and 1 by 2 into A. 1 by 2, I missed one thing. I should have put a unit vector over here, right? A unit vector A, and this 1 by 2 of the magnitude of A is called the magnitude of B, and I write this as A. So what would then be? That means I would divide this vector in half. So the representative line now of B would be this. This would be then vector B, whose magnitude is half of vector A. So whatever it may be, if we multiply a positive real number with a vector, the positive real number only changes the magnitude of the vector according to its weight. For example, what is meant by weight? If it is 2, then the magnitude is twice of the vector A, and if it is half, the magnitude is half of vector A. On the other hand, if we multiply a vector with a negative real number, that is, instead of k being positive, if it is a negative number, right? Then this thing overall, let me write it again separately. Let k now be a negative number, and that negative number is minus 2. Then I write this as minus 2 times A into unit vector A. This thing is again the magnitude, but the minus I keep separately. I call 2 times the magnitude of A as the magnitude of the resultant vector B, and the unit vector is at its own place. That means we have a vector minus B, right? Which can be written as also as B into minus A. This negative sign then tells that we need to reverse the direction of B. So what would be this vector? This vector would be a vector whose length would be equal to exactly this vector, but this would be reversed in direction. Then this vector is in fact minus B, whose magnitude is also equal to 2 times A. Similarly, if the K is a negative number in the form of minus 2, then we write this as magnitude of A times vector A, and this would then, this half times this thing would make the magnitude of B, so we write this as minus B in writing the same unit vector at this position. Then this thing is in fact vector B with a negative sign, so we write this as minus B. This negative sign can also be expressed as the magnitude of B times minus A, unit vector A. So we need to have a magnitude of half of A with direction reverse. That means I would have then this one vector. This would be then minus B. So there is, I want to conclude this thing. When we multiply a vector by a positive real number, the positive real number only affect the magnitude. If that is a fraction less than 1, the magnitude would reduce. And if that is a fraction or a number greater than 1, the magnitude of the vector would increase. Like in this case, it has been increased. In this case, it has been reduced. So positive real number just changes. The multiplication of positive real number to vector just changes the magnitude of the vector, the length of the representative line of the vector. On the other hand, when we multiply a negative real number to the vector, the negative real number changes the magnitude of the vector according to its weight and also reverses its direction. So a negative real number reverses directions and also changes magnitude. Now, a very important thing that you need to memorize, if this K multiplied with A were minus 1, what would we have then? Then this would be equal to minus 1 times magnitude of A into A unit vector. This would be equal to, again, this is minus 1 times minus A magnitude of this, which is in fact equal to minus of A. And we know from our previous video, minus A is in fact the negative of vector A. Means minus A is a vector whose magnitude is exactly equal to A and the direction is opposite to A. So we would have this thing. This vector would be minus A. So the negative of A. That means the negative of a vector is obtained by multiplying that vector with minus. Thanks for watching.